and welcome to our lecture series. I am Professor Mohitsingh Katoch from the Department of Civil Engineering at Tulsiramji Gaikwad Patil College of Engineering and Technology, Nagpur. Today, we are beginning a journey into arguably the most critical subject for any modern engineer, Sustainable Development Goals, or SDGs in short. We will be starting with Unit 1, focusing on the fundamental definitions and the multidimensional aspects of sustainability. As future civil engineers, you aren't just builders, you are the creators of the environment humanity lives in. Let's understand how to build for the long haul. So, as I told you earlier, today's topic is going to be definition and aspects of sustainability. By the end of this session, you will be able to explain the technical etymology of the word sustainability, analyze the famous Brundtland Commission's definition through an engineering lens, evaluate the three core pillars, that is environmental, social, and economic. Most importantly, we will discuss your role as civil engineers in achieving intergenerational equity, leaving the world better than we found it. Why is this a core subject for civil engineering? Because we are at the front lines. First, resource scarcity. Natural sand, water, and limestone for cement are finite. We must move from an extract, use, waste model to a circular one. Second, the environmental impact. Did you know construction accounts for nearly 40% of global CO2 emissions? We aren't just part of the problem, we have to be the solution providers. Finally, design life. We don't build for today. A bridge designed by you today must still be safe and functional in the climate reality of the year 2075. Let's look at the word itself. It comes from the Latin sustinere, meaning to hold up or endure. In engineering, sustainability is the capacity to endure. It isn't just about being green or planting trees. It refers to creating systems like a water supply network or a highway that maintain their function and value for generations without depleting the very resources they depend on. It's a dynamic state, not a static destination. If there is one definition you must memorize, it is this one from the 1987 Brundtland Commission. In the image, we can see Gro Harlem Brundtland, who gave this definition, which was sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. It's a simple sentence, but it changed the world's approach to growth. The Brundtland definition hinges on two concepts. First, needs, specifically the essential needs of the world's poor, that is, clean water, safe housing, and sanitation. Second one was limitations, the idea that our environment has a carrying capacity. As engineers, our job is to use technology and better social organization to push these limitations, ensuring we don't consume resources faster than nature can regenerate them. Now moving on to the next topic, that is aspects of sustainability, the three pillars, that is the triple bottom line aspect. In the past, engineers only looked at the bottom line, which was cost. Today, we use the triple bottom line. For any project to be truly sustainable, it must balance three pillars. First one is environmental, that is planet. Does it protect ecological health? Second one is social, that is people. Does it improve human well-being and equity? And the third one is economic, that is profit. Is it financially viable in the long run? If you miss even one of these, the project will eventually fail. Let's look into the environmental aspect. Under the environmental pillar, we focus on preserving planetary boundaries. This means conservation, that is protecting biodiversity during site clearance. Waste management, that is minimizing landfill through the three R's, that is reduce, reuse, and recycle hierarchy. And the next is emissions, that is cutting the carbon footprint of our buildings. Let's look into these few examples. Let's look at concrete. We know cement production is a carbon intensive activity. As sustainable engineers, we replace a portion of cement with industrial waste like fly ash from the power plants or GGBS from steel plants. In second example, we can see that instead of mining new mountains for stone, we can use recycled aggregates from crushed old buildings. This reduces embodied energy, which is the energy required to produce and transport materials to the site. We can also use low VOC paints for improving the air quality. Can you name some other materials which can be used as sustainable materials in the construction line? Please comment below if you know them. Economic sustainability isn't just about the lowest bid, it's about life cycle cost analysis, that is LCCA. Suppose you build a bridge. A cheap bridge with low quality paint might save money today, but it will require massive maintenance costs every 5 years. A sustainable design might have a higher initial cost but lower operational and decommissioning costs, which creates better value over 50 years. Social aspect. The social aspect is about equity. Does the new highway divide a community or connect it? Does the building follow universal design, meaning can an elderly person or someone in a wheelchair navigate it easily? We also focus on heritage, that is ensuring our new glass and steel structure don't destroy the cultural fabric of our historic cities. So this is all about social aspects. We should focus on people and equity. Finding the sweet spot. When these pillars overlap, we find the sweet spot. First one is viable, that is economic plus environmental. The project makes financial sense and respects nature. Second one is equitable, that is economic plus social. The project should benefit, the benefits of the projects are shared fairly by all stakeholders. Third one is bearable, that is social plus environmental. The environment supports human life without being destroyed. So these are the sweet spots which must be achieved. Intergenerational equity. This is a moral concept. We hold the earth in trust for the students who will be sitting in these chairs 100 years from now. Think of a large dam. If it provides electricity today but fills up with silt in 30 years because of poor upstream management, we are leaving a siltation nightmare for future engineers. Sustainable engineering prevents that. How do you measure the sustainability? We use life cycle assessment, that is LCA. We look at a building from cradle to grave, from the moment we extract raw ore through manufacturing, construction, 50 years of use, and finally its demolition and recycling. We want to minimize the environmental load at every single stage. So, in this topic, we can get more clarification about the concept. The green building focuses on energy efficiency, water saving, and material health within a specific structure. But sustainability, it is a broader a system level concept involving policy, urban connectivity, and socio-economic impact. In the low impact development, it is a civil engineering strategy to manage stormwater runoff as part of a green infrastructure where our structure mimics nature. How can we provide it? We can provide it by using permeable pavements, rain gardens, and bioswales, and constructed wetlands. Our specific goal is SDG 11, that is Sustainable Cities and Communities. By 2050, 7 out of 10 people will live in cities. You will be the ones designing resilient, disaster proof infrastructure, integrated public transit, and using the Internet of Things to monitor water and energy waste in real time. Einstein famously said, "We can't solve problems with the same thinking we used to create them. We need systems thinking." An engineer can't just look at the site boundary. You must look at how your building affects the local water table, the city's traffic patterns, and the local economy. Finally, remember that sustainability is now part of our professional ethics. Global bodies like the ASC and IEI now mandate that engineers must prioritize public safety and environmental welfare. You are the bridge between science and society. To summarize, sustainability is about endurance. It requires a balance of the triple bottom line, that is planet, people, and profit. We must prioritize the needs of the poor and respect the limits of our technology. In our next lecture, we will look at the history of how we moved from the Millennium Development Goals to the current SDGs. Thank you for your attention. If you have any questions about how these pillars apply to your specific civil engineering project, leave a comment below or reach out in our next lecture session. Don't forget to like and subscribe for more technical lectures. Happy learning.